Alright, so we are currently working on the wheel and axle on simple machines here on this sample problems that we have through Project Lead the Way, and I'm going to work you through this. First question here is, what is linear distance traveled in one revolution of a 36-inch diameter wheel? So if you recall, we've got a 36-inch diameter wheel, and it is asking us to translate this turn. If we were to start on this side and walk all the way around that 36-inch diameter wheel, they want to know the linear distance. So this is basically the equivalent of us taking and starting on this side and just laying out, or more or less rolling this wheel till we get that straight line from rolling the wheel. So to do that, we've got to determine the circumference, and that's simply the formula here. So our circumference equals 2 pi r is one formula that we can use. We could also use circumference equals pi times the diameter. Either one of these will work on that as we go through. So as we start, when we get into there, so substitute and solve, I'm going to use 2 pi r just because that's the one that I'm familiar with. But so C equals 2 times pi times r. In this case, the diameter is 36 inches. So the radius of a 36-inch diameter is half of 36. So that's just 18 inches. And don't forget, we need to maintain our units. So there is our substitute and solve for circumference. Our final answer here, C, I'm just going to get my calculator out, 2 times pi times 18 inches equals 113.097. I'll just go ahead and stick with 3 decimal places, or 113.097 inches. Now, technically, because we were only at 18 inches here, we could more or less just round this off to 113 inches as the actual linear distance that would travel if we took a line of string and wrapped it around a 36-inch wheel. So that's that one. Let's move on to number 11 here. An industrial water shutoff. Some of these issues are just a matter of learning how to read the actual problem and decipher the information that we need out of it. So an industrial water shutoff valve is designed to operate with a 30-pound effort force. So right there, that's telling us our effort force, this way designated as F of E, equals 30 pounds. The valve will encounter 200 pounds of resistance. So our resistance force, our F of R, is 200 pounds, applied to a 1.5-inch diameter axle. So that, of course, is our resistance diameter of 1.5 inches, or 1.5 inches. So alright, so we've got several things there. We also know our DE. Now right off the top of the bat here, we see that we have our F of E and our F of R. So we should recognize here in problem 12 that we can automatically come up with our actual mechanical advantage, which is AMA free, so FR of FE. But before we get to that, we still have to sketch and annotate this wheel and axle system. So I'm going to draw here, I'm going to draw my shutoff valve, and you don't have to get fancy. Of course, you know, if you want to get fancy and draw it exactly like a shutoff valve would work, that's okay. No, you don't for these. So, and we got our axle here. So so the shutoff valve itself is the wheel, and it's on that stem, which is the axle that goes into it. And here we don't know what our effort force is, or the diameter of this valve. So our effort force is up here. As we annotate this, this is 30 pounds. applied to this, so we don't know the DE yet. We don't know what this diameter. We know that the force of our effort, let me erase this because I'm labeling things wrong here. So we got to make sure we label correctly, so I don't want to confuse you. So this diameter here is the diameter of our effort. We don't know what that is yet. Our force, we're going to turn this here with an effort force of FE equals 30 pounds. And here we know that the diameter of our resistor, as we got our resistance force here, our FR, which equals 200 pounds. And we don't know what the distance of this is here. So let me move these arrows out just a little bit. This is our DR, and that we know is 1.5 inches. Alright, so that's basically what we're looking at, a simple annotation here with everything labeled correctly. So coming down, what's the required actual mechanical advantage? AMA equals FR over FE. We simply substitute here. AMA equals, FR is 200 pounds. Our FE is 30 pounds. Again, make sure you are including your units, because that way you know that the units here, when you divide 200 pounds by 300 pounds, the units cancel out as well. So we're going to be left with no units, which makes sense because mechanical advantage shouldn't have any type of unit on it. And we are getting mechanical advantage of 6.666 repeating, or 6.667. So our actual mechanical advantage here is 6.667. So problem number 13, what is the required wheel diameter to overcome the resistance force? Well, here we can use a couple of formulas. We still have our IMA equals AMA formula that we could use, and with that we're just going to basically take and substitute DE over DR equals FR over FE. Now, keeping this in our formula here, I want to cross multiply and show you what happens when we cross multiply. When we cross multiply here, we end up with DE FE equals DR FR. Now, hopefully some of you are recognizing what we have when we take a distance times a force. Distance times a force. Well, distance times force is our definition of a moment. So we could also say the moment about E times the moment about R, the moment of our effort force times the moment of our resistance force. So is also one of the formulas here. DEFE, our distance times force, equals the distance of the resistance times the force of the resistance. So if you're asked what's the moment of our effort force, well, you just take ME equals DEFE. These are all substitutions, ways that we can substitute. But here we need to find the wheel diameter to overcome the resistance force. So I'm going to go ahead and use DE over DR equals FR over FE, because I know both my forces. So DE, our effort force, is what we do not know. Our DR is 1.5 inches. Our resistance force is 200 pounds. Our effort force is 30 pounds. Cross multiplying, doing the long form of algebra, I get 30 pounds. DE equals 1.5 inches times 200 pounds. Okay, now I need DE by itself. So my algebra here, again, DE, I got to take both sides of the equation and divide by 30 pounds. So I'm going to get 1.5 inches times 200 pounds divided by 30 pounds. And of course here, my pounds are going to be dropping off, so let's go ahead, let's plug this in. 1.5, this is just plug and chug here, times 200 equals 300, and we're going to divide that by 30, and that gives us a DE of 10 inches. So that's actually a pretty large diameter shutoff valve, a 10-inch diameter shutoff valve to give us that. But of course, if you think about it, a 1.5-inch axle, that's a pretty decent size axle that would be driving it. That is, you know, right here is 1.5 inches. So imagine a diameter. We'll just kind of, I don't even really have room on this paper to draw it, but if I did, you know, we got 3/4 of an inch right here. That is the radius. You know, that's a pretty large diameter axle, so it makes sense that you might have a 10-inch diameter wheel driving that particular 1.5-inch wheel to get some mechanical advantage there. So that's how we solve this wheel and axle problem. That's problems number 10 to 13 on the simple machine practice problems that you need to know. Go ahead and try it, do it on your own, set up a couple of different things, and we'll go through some more of these practice problems so you know how to do these when we get to the test.